and mu2. So you're basically dealing with two populations, like men versus women, young people versus old people, dogs versus cats, type of situation where you want to compare the averages. Maybe you want to measure the average, trying to think of something that would be funny with cats and dogs. I have 3 cats and 3 dogs. Let's see, I could measure the weight of their poop. Is the average for a cat more than the average for a dog, or less than the average per day? And you know, you would think dogs would be more, but these cats, I mean, I've got indoor cats and I'm cleaning those litter boxes daily. I don't know, my yard is full of poop from the dogs, so who knows? But anyway, so maybe I want to compare that average. Or maybe I've got men versus women and I want to compare their average IQ, or their average GPA, or some average in those groups. Come on, man. Where are the other guys? All right, so in this case, your claim is either going to be that they are equal, which would be an HO claim, or that one is greater than the other, or that one is less than the other, or that they are not equal. Right? And these 3 would be your alternate hypothesis claims. So very similar situation, you just don't have a value, you just have a comparison. So it's either that, or that, or that, or that. All right, and then you have to be given 2 sets of sample data, one for each group. Sample of cats and a sample of dogs and weights of their poop, or sample of men and sample of women and their GPAs. And you just have to keep track of which one's group 1 and which one's group 2. Sometimes they will use subscripts for you, sometimes they won't. I'll come back. So group 1, you're going to have a sample mean and sample standard deviation and sample size, and they are going to be subscripted with the number 1 in your calculator. And then group 2, you've got a sample mean, sample standard deviation, and sample size. And they are going to be subscripted with a 2 for the second ones. So these will all be given. You just have to identify which is from which group. And then you're also going to be given alpha. Okay? Otherwise, it's just the same. You go to your calculator. This time we're going to use 2-SAMP t-test. Okay? We're not even going to talk about the situation when we use 2-SAMP z-test, which you can probably guess would be what we would use if we were given sigmas here instead of s's. So you're going to be given s's. So we're not going to use 2-SAMP z-test.
Not even on the test or nothing?
No. Nope.
So is the X bar and everything always given to you?
Yep.
Or is there
These are all going to be given.
always-
They have to. Yeah, this is like bars and twos. Given. Right? Sometimes they'll give it to you in paragraph form, sometimes they'll give it to you in table form, but they have to give you those statistics. Okay? So let's look at one. Then again, it's your t-test is going to calculate the test statistic and the p-value for you. You compare it to alpha and make your conclusion, just like before. So here to your class, just pull up a random problem from 9.3. That's the last section, woohoo!
Is this? So Wednesday, are we gonna like review it sometime?
Yeah, so Wednesday is a review for this unit and for the final.
Nice.
Yep. Alright, I'll do number 10.
It will be, should be at least like,
Gotta say, this class has been a fun ride.
Well, it's raining.
Lacey looked at it too hard and stuff.
Waiting. So try again. Okay, forget number 3, let's do number 4. Yeah, number 4 comes up, no problem. Perfect. Alright, a study was done on skull sizes of humans during different time periods. The results are shown in the table. Okay, so they gave it to you in table form. So we've got some measurements for skulls found from 4000 BC, and then skull measurements found from AD 150. Alright, assume that the two samples are independent, simple, random samples. Again, that's something that has to hold true for this to work. Selected from normally distributed populations. So that's just given background. We're just like check, okay, go on. Do not assume that the population standard deviations are equal. There's something in your calculator test I'm gonna have to show you where it says the word pooled. And you always wanna make sure it says no. That's where we're not assuming anything about equality of standard deviations. That's gonna be the default, but I'll show you when we go in there that you wanna keep that set. Alright, so otherwise, we wanna notice that we've got the older skulls that they're giving first, so we'll say those are group 1. And so those are gonna be subscripted with the number 1, N sub 1. The first sample size is 35. And then they give the sample mean, X, the bar is way up on the table, but it's there, 132.8884. 32.84 millimeters. With a standard deviation of 5.48. Alright, so that's from 4000 BC. And then they've got skulls from still a while ago, but a little bit more recent, 150 AD. That's gonna be group 2. Their sample size is also 35. But the mean there is 135.97. So that's X bar sub 2. Looks like they're a little bit bigger on the average, with a standard deviation of 5.45. Alright. Part A, use a 0.05 significance level, as usual, to test the claim that the skull breadth in 4000 BC is less than the mean skull breadth in AD 150. Okay, so the claim is that the mean from this group, overall, population mean of all skulls from that time period, is less than the average from all skulls, right? So sure enough, it's true for the sample, and the question is that a statistically significant difference? Is that enough to say that it's true for the populations of all skulls from that time period? So again, this is a less than claim, so is that HO or H1? H1. And so HO is equals, in this case it's that mu1 is equal to mu2. So the null hypothesis is that they're not any different, right? They're the same. That's what we're going to assume is true for the purposes of calculation. And then see how extreme this difference is based on that assumption. Alright, so we go to SAMP t-test. By the way, this first is less than versus equals, or equals versus less than.
D.
D. Alright, but we need the calculator for the next part. Stats. Test. To SAMP t-test. Be careful about that. Pick number 4, not number 3. Again, you want to make sure stats is highlighted so that it asks you for the statistics as opposed to a list. So what's X bar sub 1? Bar 1? What is it?
132.84.
Thank you. What's the standard deviation?
5.48.
deviation? 1.5. Okay, so size 35 again. Alright, now you gotta just keep scrolling down. So here we've got the same inequalities. Now, of course, it's comparing mu1 and mu2 as opposed to with mu sub 0 or p sub 0. Because we don't have a mu sub 0 or a p sub 0 in this case. So it's the less than. And scroll down again, and here's what I was talking about with the pooled option. Just keep that as no. Okay, just always. And then calculate. Alright, so we have a test statistic of negative 2.396. Negative. This is again what we would call a left-tailed test. And that's pretty far to the left. More than 2 standard deviations to the
How
left
do you know
of the
when it's,
mean.
when you do it to the left?
Less than.
Oh, okay.
Yep, yep. Alright, and the p-value again is the area beyond there, which is quite small, isn't it? 0.00966. 967 rounded. Alright, so definitely less than alpha. P-value is less than alpha, right? 0.0097 or whatever is definitely less than 0.05. So what do?
Reject.
Reject HO. And what else? Support H1. Alright, so which one do we care about? Which one's our claim? H1, right? So we want to word our conclusion in terms of the fact that we can support it at alpha equal 0.05. There is enough evidence to support the claim. That skulls were smaller on the average, of course. On average in 4000 BC than in 150 AD. What do you know about that? Well, where's the fact? I'm paraphrasing the claim. You can do that, or you can just repeat it verbatim. Not too bad. So the PowerPoint's going to go into a little bit more detail. Alright, so they're going to say, alright, well, there are some situations where the standard deviations are unknown and not assumed to be equal as opposed to known. We're just going to do the first part where they're unknown and not assumed to be equal so that we can use t-test and then no for pooled. So that's what we're doing. The stipulations for this to work is that you have to have what are called independent samples. Basically, they can't come from paired data. Remember in chapter 10 when we did linear regression, we had paired data. That type of thing you can't use for this situation. They give examples here. Independent samples would be if you had 2 separate groups of students. One group that took proctored tests and one group that did not. And compared maybe their average score or something, that'd be okay. But if you had something like this, heights of husbands and heights of wives, those are dependent, so this method would not work for those. Just FYI. Here's your notation, subscripted with 1s for group 1 and with 2s for group 2. And we're assuming all these things hold. And there's the lovely formula that's built into 2SAM t-test. The one nice thing is that this mu1 minus mu2 is always assumed to be 0, because the null hypothesis is always that they're equal. So if they're equal, their difference is 0. So that part actually doesn't play into the formula, but it's still somewhat cumbersome. And we don't have to use it. Alright. Here's an example. This is in your handouts. Page 13. Researchers conducted trials to investigate the effects of color on creativity. Subjects with a red background were asked to think of creative uses for a brick. Other subjects with a blue background were given the same task. Responses were given by a panel of judges. Researchers make the claim that blue enhances performance on a creative task. This data is actually in your book, in the chapter opener for chapter 9. If you have your books, it's kind of an interesting situation. I'm gonna give some more data. I'm gonna do two tests using both sets of data. The first set of data is these creativity scores for red background versus blue background as they're describing here. Some studies are quite intriguing as they reveal various facets of human behavior. One such study is reported in the article Blue or Red, exploring the effect of color on cognitive task performances. The researchers from the University of British Columbia conducted studies to investigate the effects of color on creativity and cognitive tasks. To investigate the effects of color on creativity, subjects with a red background were asked to think of creative uses for a brick. I used bricks to line a flower bed by my mailbox. How's that? I don't know what else you do with bricks. While other subjects with a blue background were given the same task. Both groups were allowed 1 minute to think of a creative use for a brick. Responses were scored by a panel of judges, so somehow they're measured by these judges as to how creative their idea was. Results from scores on creativity were as follows. All right, so we have these two groups, red and blue. And I'm gonna write down both of these tables because then it goes on to say in other trials, subjects were given detail-oriented tasks consisted of words displayed on a computer screen with background colors of red and blue. The subjects studied 36 words for 2 minutes. Then they were asked to recall as many of the words as they could after waiting 20 minutes. That would be hard. Given how many words? 36 words. You look at them for 2 minutes, and then you wait 20 minutes, and then how many of those could you recall? Results from scores on the word recall test are given below. All right, examining the above results, we can see that creativity scores were higher for those having a blue background. And then, let me read the rest. It's obvious that the mean of 3.97 is greater than the mean of 3.39, but is the difference significant, is the question. We can also see that the accuracy scores were higher for those having a red background, the accuracy scores. So red is apparently maybe better for accuracy. The mean of 15.89 is greater than the mean of 12.31. That might be the number of words that they remembered. Actually, I don't know how they do the creativity scores. But it, again, is the difference significant? Okay, so we have these creativity scores for red versus blue. And they're letting the red group be group 1, and the blue group be group 2, and then we have accuracy scores. Again, red versus blue, background. All right, for creativity, sample sizes in both cases were 36 for the blue, and 2 is 36. One more person had the blue background. Sample mean X bar 1 is 3.39, X bar 2, 3.97. So again, looks like it's a little better for blue. You know, is that enough to say that it's true for anybody who uses a blue background? And standard deviation comes into play. How spread out they are, 0.97.